Today we're going to talk about double replacement and combustion reactions. So let's start first with double replacement. Double replacement, sometimes called double displacement, is when two molecules switch opposite ions. Okay, so we are dealing solely with ionic compounds, okay? And we're going to deal with two types of double replacement. Okay, our first type is going to be a formation of a precipitate. Now, a precipitate is when a solid falls out of solution. So essentially you take two liquids, two solutions, mix them together, and a solid forms. That's a formation of a precipitate. That occurs because of a chemical reaction. So just like your single replacement, it's vitally important to know your positives and your negatives. Okay, so in a compound we've got our cation and our anion, and our cation and our anion. Okay, and when these two things mix together, it's going to create that solid precipitate. So we're going to have AD plus BC. We still have our positives and our negatives. Okay. Oh, excuse me, CB. See, it's easy to make a mistake. That's why you have to know your positives and your negatives. Okay. So one of these is going to be insoluble and it's going to fall out of solution, and that's where that comes from. That's where how that precipitate is formed. Okay, so the best way to express this is, let's just go ahead and give a quick example. Let's show potassium nitrate plus sodium phosphate. So I've got two compounds here, an AB and a CD. So if you're looking at what we have predicted in our product, then you are going to have your A, B, C, D. So our product is going to be potassium phosphate plus sodium nitrate. And then we just need to write our formula. So potassium nitrate, potassium is a +1, nitrate is a -1. Put them together, I get KNO3. Sodium phosphate, sodium is a +1, phosphate is a -3. Put them together, Na3PO4. Potassium phosphate, potassium is a +1, phosphate again is a -3, K3PO4, and sodium nitrate, sodium is a +1, nitrate is a -1. Put them together, I get NaNO3, and now we're going to balance it. And balancing it, there's going to be 3 potassium nitrates and 3 sodium nitrates, and that should be balanced. It should be good to go. Okay, so to make sure that you understand your positives and your negatives. Okay, the second type we're going to do, we had formation of a precipitate. Now we're going to do an acid base neutralization. And when this happens, we're dealing with some form of an acid, some ionic acid, and a base, which for our purposes is going to be a metal hydroxide. Okay, now when these two things meet together, you're going to end up with a metal and the ion from your acid plus water. That's your product, water, and then the something else. All right, so let's look at an example. Let's do nitric acid plus sodium hydroxide. That's going to make a metal ion. Well, let's figure out what that ion is first. We also know that it makes water. Okay, let's look and see that ion. So nitric acid means nitrate. So all acids have an H. Nitric means nitrate, HNO3. So that is your X variable. That is that ion. So I've got sodium nitrate. All right. Sodium hydroxide, Na plus 1, hydroxide minus 1. So let's put these two formulas together. I have HNO3 plus NaOH. Now I'm going to make my product. Sodium nitrate. Sodium is plus 1. Nitrate is NO3 minus 1. Put it together. NaNO3 plus water, H2O. And to balance it, I believe everything is balanced. It should be good. And that's our final result. So for formation of precipitate, you need to look at your positives and your negatives. Now as time goes on, we'll talk more about solubility and solubility rules. But for now, just make sure you know the process. That those A's and the B's and the C's and the D's and how they're going to switch. Okay, for acid-base neutralization, your product is going to be something and water. Okay, now let's look at combustion. Combustion, we're only going to deal with one type. We're going to deal with hydrocarbons. So in a hydrocarbon, which is some type of carbon attached to some type of hydrogen, okay, is ignited to produce carbon dioxide and water. All right, so we have some type of hydrocarbon.
Attention students who normally ride bus 86 need to ride bus 241 today. Again, students who normally ride bus 86 need to ride bus 241 today.
Now let's look at combustion. Combustion reactions. So it's when a hydrocarbon is ignited to produce carbon dioxide and water. It's pretty straightforward. So carbon, a hydrocarbon, I have some type of hydrocarbon, C2H3, C4H8. There are tons and tons of different ones, okay? And it's going to be ignited. Well, in our world, the addition of oxygen is the introduction of flame. So that is the fuel source for fire. To produce carbon dioxide and water. It's pretty straightforward, okay? So let's look at an example. Let's do propene plus oxygen. Well, my result is going to be carbon dioxide plus water. So propene is C3H6. And don't worry so much if you don't know all of the hydrocarbons. It's okay. A lot of them will be provided for you. Plus oxygen yields carbon dioxide plus water. Now sometimes these can be a little involved to balance, okay? This particular example has 2 propenes, 9 oxygens, 6 carbon dioxides, and 6 waters. This one's can be fairly hefty to try to balance. Some of them even more than that, 25 oxygens and 50 oxygens. Those are uncommon, but that does happen. So if you're not getting it to balance, don't fret. You might just need to keep going. Okay, sometimes they can go on for a long period of time. Okay, and that's about it. Okay, Combustion is pretty straightforward. Hydrocarbon and oxygen yields carbon dioxide and water. Okay, so double replacement and combustion, and that's all of our reactions. Next class, we're going to talk more about making sure that you can recognize each of those reactions, put them all in one place, and make sure you know what all the products are of all of the reactions. Okay, until then, make sure you work together, help each other, and make the world a better place. See ya.